This is the Satoshi9000. It is a machine with a simple value proposition. This machine provides randomness in a way that is easily seen and understood by anyone from 5 years old to 95 years old, technical or non-technical. Let me show you how it works. Power on and boot. Let me show you the Satoshi9000 control panel. The red power LED shows when there is power available to the machine. When you press the on button, the green ready LED flashes while the machine boots, and the boot sequence is displayed in the log file window. During the boot process, the firmware for the machine, called Chaos, is read from one SD card, and the user programs written in a language called Entropy are read from another SD card. The available Entropy programs are displayed in the Select Program window and can be selected using a scroll wheel. Incidentally, once the Run button has been pressed for the selected program, the scroll wheel function switches to scrolling back and forth through the log file window. Hitting Run will execute the program shown in the Select Program window. Hitting the Stop button at any time will immediately erase all internal state for the machine and power the machine off. Once the program has finished running, the key generated and any information desired from the log file is printed on the small thermal printer, at which point all internal state data is erased and the machine powers itself off. Select and run a program. The entropy programs written to control the machine provide full control over nearly every aspect of the Satoshi9000 operation. So you can generate keys and data for a wide variety of applications, such as a Bitcoin key, a program to test if there's bias in a coin, generate data for a clinical patient trial, generate a key for a specific router and manufacturer, test dice for bias, generate a Dogecoin key, generate a Ethereum key, play Conway's Game of Life, create a multipart key, simply generate 1024 bits of random data. In addition to writing programs in Entropy, you can also control the machine through a Python API. Play rock, paper, scissors. Spin a roulette wheel. Shuffle a deck of cards. Play a Scandinavian form of chess. Run a self-test for the machine. Make a random decision from many choices. Generate a USD coin key. Generate a Monero key. Once you've selected a program to run, you can simply run it by pressing the Run key. Once the machine has finished running, it prints its output, erases its internal state, and powers itself off. You can then remove the coins from the shakers. Incidentally, when your program is running, you can pause it at any time and substitute the coins or dice that you're using to generate the randomness and continue. Here, I can take the coins that we use to generate the randomness. I call this walk away bias. Also, you can take the printout, you can remove the SD card with the firmware, and the SD card with the user programs. It all fits in the palm of your hand, and you can take it with you. I call this walk away randomness. Finally, the Satoshi9000 Generation 5, this machine, is air-gapped in the sense it has no connectivity to the outside world. No Wi-Fi, no Bluetooth, no network connectivity whatsoever. This, together with what I'm calling walk-away randomness, means an adversary has few clues as to how, why, and when the machine was last used. If you have any more questions, simply contact me.